Hi everybody, welcome to another video in differential equation, section 2.4, exact equation. If you took calculus 3, this section will not be very difficult. If you haven't taken calculus 3, it will be a little bit difficult. I will put the video that I have in my calculus 3 class in the description, so I highly recommend that if you did not take calculus 3 or it has been a long time, or if you just want to review, it will be very useful to look at the links in the description. Right, let's go straight to the problem here. So exact equation. So I say we have the function of two variables x and y. This is a function. Now there's a typo here that I will change before I post the note online. So this is the capital F of xy is equal to x squared plus xy. Now if we take the partial derivative with respect to x, so with respect to x, derivative of x squared is 2x. That's easy. With respect to x, y is a constant, so the derivative of x is 1 times the constant y. So that's just 2x plus y. And derivative with respect to y, x squared is a constant, so that's 0. Derivative with respect to y, x is a constant. Derivative of y is 1 times that constant, x is x. Now, if that is the case, then we can write the total differential as df is equal to that. Now, if the function is equal to a constant, then that equal to 0. Why is that? Because if the function equal to a constant, the derivative of the constant is equal to 0. So in other words, we have this equal to a constant is the solution of the differential equation here. Right. So the way we write the solution, we're not writing f of xy equal to something. We write in implicit form an equation, something like that is the solution to the exact equation. Now let's define exact equation. Like I said, if you took calculus 3, this will be very easy because we did exactly this. So the first thing we need is know how to do the partial derivative. So I put the link in the description. Also, the second thing we need is in the conservative vector fields. That is another section in calculus 3 which exactly do the same thing that we do here. Right. So like I said, I put those two videos, the link of those two videos in the description, and I highly recommend you to watch them if you haven't taken Calc 3 or you just want to review. Right. So the differential form m xy times dx and n xy times dy is said to be exact if there is a rectangular R said to be exact in the rectangular R if there is the function such that partial derivative of f with respect to x is equal to m and partial derivative of f with respect to y is equal to n. So, and for all the x and y in that rectangle, the total differential satisfies this. So what does that mean? So when we have this m of xy and n of xy, if there is a function where we take the derivative with respect to x, give us m, and where we take the derivative with respect to y. By the way, when I'll use the subscript whenever possible. Subscript y derivative with respect to y, subscript x derivative with respect to x, rather than writing those notation. Right. Now, if there is a function whose derivatives equal to m and n, then we say this form is exact, and that function is called a potential function. A potential function. And the exact equation is if the left hand side is in an exact form, meaning that there will be a function whose derivatives equal to m and n. Right, so how do we solve exact equation? Knowing that m is derivative with respect to x and n is derivative with respect to y. Right, before we go there, we need to know that it is in the right form, right? So we need to know that it is in the exact form, or it is an exact equation. So if it is exact, I mean this equation, if it is exact, it has to be from the partial derivative of f with respect to x. So if it is exact, then there is a function where we have derivative with respect to x is equal to m, and derivative with respect to y is equal to n. If it is exact, we don't know that function, but if it is exact equation, there will be a function like that. Next, if it's like this, we will take the partial derivative with respect to y on both sides here. So we'll write f of x y equal to m y, and here I'll take derivative with respect to x. Derivative with respect to x, f of y x equal to n x. If it is up to me, I will prefer taking calculus 3 before take differential equation. It will be a lot easier. Now, Claro the mixed partial derivative are equal f of xy equal f of yx, because these two are equal. My must be equal to nx. So this is the condition. So if the equation is exact, my is equal to nx. Right. So that's how we test to see if the equation is exact or not. Is we take m with respect to y and compare to n with respect to x, and m is the one that goes with the x and n is the one that goes with the y. Right, now how do we solve it? So to solve for it, if we have the equation, if it is exact, then yes, it is in this form, right? So if it is exact, then there will be a potential function. So if we know this f of x, so exact equation, when we solve it, we start with either one of those two. Either one of those. And if f of x equal to m, integrate both sides, we get, so integrate with respect to x. If we integrate with respect to x, the constant will be in terms of y. And then we differentiate with respect to y. So either we let f of x integrate with respect to x and then differentiate with respect to y, or we start from here, integrate with respect to y and differentiate with respect to x. And along the line we will solve for the equation. We'll go to particular solution later, but here what I want to write in the note. So either we do one of the following. Start with f sub x equal to m. We integrate with respect to that variable and then differentiate with respect to the other variable. You see when we look at the example, either we do that or we start with f of y equal to n and we integrate with respect to y. Yeah, and to undo the derivative and then differentiate with respect to x. Yeah, either one of them will work. The more details we will see in the example, but on the backbone of the problem is will be just that. Right, let's look at the first example. There's a solution. Right, for this equation, test the equation for exactness to see if it is exact. If it is exact, solve the equation. Right. So when we look at the equation, first we have to know right now what is m and what is n. Of course, the one that go with the x is m, and the one to go with the y is n. So we have m equal to that, and n is equal to that. So to test to see if it's exact, we would test to see if derivative of m with respect to y is that the same as derivative of n with respect to x. We will test that. So we take derivative of m with respect to y. With respect to y, derivative of y squared is 2y times that constant 2x is 4xy. With respect to, and then n is 2x squared y. With respect to x, derivative of that is 4x times the constant y is 4xy. Now these two are the same. So the equation is exact, which is good. In that case, we'll do two steps. Either we'll start with this and we integrate with respect to x and differentiate with respect to y. Right. In this case, we start with this. If the derivative with respect to x, to get back to the function, we integrate. And integral of this, again, with respect to x, y is a constant, y squared is a constant. So integral of 2x is x squared, and then the constant y squared. And integral of 1 is x. Usually we add the constant. However, this is with respect to x, the constant is with respect to x, so we can have y in it. So this is the function in terms of y. Now we have the function. We will take the derivative of this with respect to y. So if we integrate with respect to x, then we differentiate with respect to y. It's just like that. Now, differentiate this with respect to y. Derivative of this with respect to y is x squared and then 2xy. So 2x squared y, right? Derivative of this with respect to y squared is 2y times x squared. So 2y times x squared. Derivative of x with respect to y, x is just a constant. Derivative of a constant is 0. Derivative of g is g prime. Now, when we take derivative with respect to y, f sub y is supposed to be equal to n, right? So we let that equal to. So the notation column equal to, meaning we make that equal to n. So now we match on both sides. 2x squared and 2x squared y, 2x squared y cancel out. We have n. We have derivative equal to 0. So integrate g of y is a constant. Finally, we write the solution is like this. So in calculus, we will write the solution like this. but in here we will say that equal to 0 and move the c to the other side. So we write this as the solution to the given differential equation. So the solution is equal to the function equal to c. Equation solution is an equation equal to constant in the implicit form. Right, so that's what we do. Right, now we have some example here. So first, solve this equation. So first thing we do is make sure it is exact, because if it is not exact, we don't solve for it, because that's what we done in this section. Right, so first this is going to be m and this is going to be n. By the way, try to write small because it doesn't look like we have a lot of space here. If you bring out the note online from the learning materials, then you can write. If you write on the sheet of papers, perfectly fine. Take all the space you want. Right, the first thing I'll do is check to see if it is exact. So first, check for exactness. Meaning that we will check for m with respect to y is that equal to n with respect to x. Right, so m is equal to xy minus secant square of x. So I will take the derivative of this with respect to y. With respect to y, the derivative of y is 1, so I just have 2x. With respect to y, secant square is a constant. Secant square of x is constant. With respect to y, the derivative of constant is 0. So that's all we have. Next, n is equal to x squared plus 2y. Take the derivative with respect to x. The derivative with respect to x is 2x. So 2y is a constant. With respect to x, the derivative of that is 0. Now, those two are the same. So the equation is exact. Second, we will solve for the potential function. Now, since the equation is exact, there is a potential function. So I will write, since the equation is exact, there exists of f of x and y such that derivative of f with respect to x equal to m equal to 2xy minus secant square x, and derivative with respect to y is equal to n and equal to x squared plus 2y. Right, like I said, this might take a little space, and the problem has two steps of differentiate and integrate. So let's fold this in half. So the problem, we have two steps. So either we start with f of x and we integrate to get back to f, or we start with this and we integrate with respect to y to get back to f. So the first step, number 1, I will choose this and integrate with respect to x. with respect to the same variable. So meaning that the function is equal to the integral of m of this with respect to x. Right, so integrate this with respect to x. Now with respect to x, y is a constant, so I will have constant. Integral of 2x is x squared, right? So I have x squared y. And integral of secant squared is tangent. I also add one video review of integration in the description. If you want to review how to integrate some certain things, just go to that video as well. Plus a constant. However, that constant with respect to x, so I will write that constant with respect to x, it will be y. So with respect to x, this is a constant. Right, so that's the first step of the problem. The second step, I will integrate this, differentiate. So second step, differentiate this with respect to x, then this will be with respect to y. So derivative of this with respect to y. So f with respect to y. Right, derivative of this with respect to y. With respect to y, x squared, derivative with respect to y, x squared is a constant. So we have x squared. With respect to y, derivative of y is 1. So x squared times 1, x squared. With respect to y, tangent is a constant. I'm just going to minus 0. Plus g, derivative of this with respect to y. And we will make this equal to n, because that's what it will be equal to. So we have x squared plus derivative g of y is equal to n. And what is n? X squared plus 2y, right? Cancel x squared on both sides. G prime y equal to 2y. So if we want to find g, integral of 2y dy, the integral of 2y is 2y squared over 2, 2 and 2 cancel, so that is y squared plus the constant c. Right, and finally we will substitute this back into g of y. Right, so doing those two steps will give us the solution. So we have the solution f of xy equal to x squared y minus tangent of x plus g of y, which is y squared plus c. Right, so that is the potential function. Now, in this differential equation class, we write the solution as that equal to 0. So we say x squared y minus tangent x plus y squared equal to c. So it's not that difficult. Like I said, if you have count 3, it will not be that bad. If not, please consider the videos in the description. Right, so that's pretty much it. And so the concept of differential partial derivative or integration with respect to one variable, we will treat every other variables as constant. And then we just differentiate or integrate like we normally do in Cal 1. Right, next, solve this equation. And once again, the first step is check for exactness. And after we check for exactness, we continue the solution on the next page. If it is exact, we solve it soundly. So first, check for exactness. So we will have m and n. So let m equal to cosine of x, cosine of y, and n equal to negative sine of x, sine of y. Check for exactness is we will check partial derivative of m with respect to y is that equal to the partial derivative of n with respect to x. So derivative of m with respect to y, derivative of cosine is negative sine, cosine of x with respect to y is a constant. So I have cosine of x times derivative of cosine of y is negative sine y. So that gives us negative cosine of x sine y. Derivative of n with respect to x. With respect to x, derivative of sine x is cosine x. So we have negative cosine x sine y. So that gives us negative cosine x sine y. And note that they are the same. So it is exact. Right. Next, if it is exact, there will be a potential function where the partial derivative equal to m and n respectively. So that the first step is to check for exactness. Second, since it is exact, there is the potential function there exists a potential function. It is a potential function because essentially we have the potential function with a constant c, so there will be a lot or indefinite number of potential function. So c could be any arbitrarily real number. So there exists a potential function. F of xy such that derivative of f with respect to x is equal to m and equal to cosine of x cosine of y plus 2x, and derivative of f with respect to y equal to n equal to negative sine x sine y. minus 2y. Right. Yeah, that's all we need. Right. So as mentioned before, we will take one of these partial derivative, integrate to get back to the function, and differentiate with the other variables. Right. So since the first problem we take f of x, integrate with respect to x, why don't we take this one, integrate with respect to y first, and then differentiate with respect to x? It will work just fine. So the first step, I will integrate this with respect to y to get back to the function. Yeah, or you integrate this with respect to x to get back to the function. Either way. F of y with respect to y. Right, so f of y is equal to that. So to get back to the function, f of xy equal to integral of this with respect to y. With respect to y, x is the constant, so I will have still just negative sine x as a constant. Integral of sine y is negative cosine y, and integral of 2y is 2y squared over 2, and then plus derivative, since this is y with respect to y, I can have the function with respect to x as a constant. So with respect to y, g of x is a constant. When we write this, I will have sine x cosine y minus y squared plus g of x. That's the first step. Integrate that with respect to y. Then our second step is differentiate this with respect to x. One with respect to y, one with respect to x. One we integrate, the other one we differentiate. Right. So derivative of this with respect to x. With respect to x, sine x is derivative is cosine of x. Cosine of y is a constant. Y squared is a constant with respect to x, so that minus 0. Derivative of g of x with respect to x, g prime of x. Right, and we will make it equal to m. Yeah, so we use this already. Now we use the outer box. So cosine of xy, cosine of x, cosine of y, plus derivative g with respect to y. Derivative of g with respect to x equal to m. I should write smaller. Cosine x cosine y plus 2x. Cancel those out. G prime of x equal to 2x. So integrate g of x equal to integral of 2x dx, which is x squared plus c. and then we will substitute this into this g of x. So the solution is f of xy equal to sine x cosine y minus y squared plus g of x, which is x squared plus c. Or in differential equation, we write solution as an implicit equation. Sine x cosine y minus y squared plus x squared equal to c. Right, so that's what we have. So it's not that bad, right? Yeah, if we're comfortable with partial derivative or integration, that should not be that bad. So once again, whether we integrate or differentiate with respect to only one variable, we treat everything else, every other variable, as constant. Right. Next, we'll solve this equation. Initial variable problem. So there's an initial condition here. Right. So still the same. The first step is check for exactness. Meaning that derivative of m with respect to y is that the same as derivative of n with respect to x. So let m equal to e to the x times y plus 1. Take derivative with respect to y. With respect to y, e to the x is a constant. We stay there. Derivative of y is 1. 1 derivative with respect to any variable, derivative of a constant, is 0. So just e to the x. N is e to the x minus 1. So we take derivative of n with respect to x. Derivative of e to the x is e to the x. And derivative of constant 1 is 0. So yes, they are the same. So the equation is exact. Next, if it is exact, there is a potential function f of xy such that the partial derivative will equal to m and n respectively. So the equation is exact, so we say there exists a potential function such that derivative of f with respect to x is equal to m and derivative of f with respect to y is equal to n. Right, and then to solve exact equation, we do this two step: integrate, differentiate with respect to x, with respect to y, in some certain order that we want. So first step, let's say this time I would use this one, f of x, and integrate that with respect to x, and then differentiate with respect to y and compare to this one. So first step, integrate f of x with respect to x, or we integrate this with respect to y, it doesn't matter. And the second step, differentiate f of xy with respect to y. Right, so those are the steps. Right, first one, f of x is equal to that. So to get back to the function, we integrate with respect to x. With respect to x, y is a constant. Integral of e to the x is still e to the x. So we still have e to the x, and y is still a constant. Integrate 1 with respect to x. Integral of 1 is x, and plus a constant with respect to x, g of y. Right, simple enough. Now we differentiate this with respect to y. Derivative of this with respect to y. X is a constant, or e to the x is a constant. With respect to derivative is 1. Derivative of x with respect to y is 0. Derivative of g with respect to y, g prime of y. We will make this equal to n. So we write e to the x plus g prime of y equal to n, which is e to the x minus 1. Cancel e to the x on both sides. G prime of y is equal to negative 1. So integrate, and we can find g of y. G of y is equal to integral of negative 1 dy, or we have negative y plus c, and we can substitute that into g of y. Right. So the solution is f of xy equal to e to the x times y plus x plus g of y. G of y is negative y plus c. Or we write the equation as e to the xy, e to the x times y plus x minus y equal to c. Right. So that is the general solution. Now we have the initial condition that we need to encounter for. So y of 0 is equal to negative 1. Meaning that x is equal to 0, y equal to negative 1. Substitute into this equation e to the 0 times negative 1 plus x minus y equal to 0. So e to the 0 power is 1 times negative 1 is negative 1. Where's the c? Sorry. So negative 1 minus negative plus 1 equal to c. So c is equal to 0. And finally, if c equal to 0, substitute in this one. So the equation, the solution for the initial value problem is e to the x times y plus x minus y, c is 0. So we just have e to the x times y plus x minus y I mean, I substitute 0 in here, right? Equal to c, which is 0. Right, so that's what we have. Right, so exact equation, we do two things: integrate, differentiate, respect to x, respect to y, in any order we want to. Next, look at this equation. Solve this equation if it is exact. By the way, if we only have this much space, more than likely it is not exact, so we don't have to solve for it. That's why we only have this much space. Right. So first, I'll check for exactness. Right, we let m equal to x plus 3x cubed y, and exactness where we check for my and nx. So derivative of this with respect to y, x is a constant. Derivative of, with respect to y, x is a constant. Derivative of constant is 0. 3x cubed is a constant. Derivative of y is 1. So we have just 3x cubed times derivative of y is 1. Because 3x cubed is a constant. So that's 3x cubed. Now n equal to x to the 4th first. It is sine y. I wonder when I look at the cosine, I said, yeah, forgot that there's a trig function here. Right, so x plus 3x cubed sine y, derivative 3x cubed is a constant. Derivative of sine y is cosine y. Yeah, so yeah, that is derivative of m with respect to y. X to the 4th cosine y. Derivative of n with respect to x. Derivative of x to the 4th is 4x cubed. Cosine y is a constant. Right, and they're not the same. So in that case, this equation is not exact. Sorry, the program crashed at the last minute, so I just have to record the last minute again. So once again, derivative of m with respect to y is not the same as derivative of n with respect to x. In that case, the equation is not exact. So we'll not be able to solve it using this method. Of course, there might be a way to solve it, but that's only during this section. So once again, if the equation is exact, this condition is satisfied. And if it is exact, there is potential function satisfied. Derivative of x with respect derivative of f with respect to x is equal to m. Derivative of f with respect to y equal to n. And to solve it, we differentiate and integrate. Actually, integrate first and differentiate. One with respect to x, and then one with respect to y. Integrate first, and then differentiate. Whether with respect to x first or y, it doesn't matter. But so it's not that difficult. So if you want to review more about this, there are a few videos in the description. But I will stop this section here. As always, thank you for watching, and see you in another video in differential equations.